Australia's most powerful radio telescope in Western Australia has been used to create the largest and most detailed map of cosmic magnetic fields ever made. So, how do we map these seemingly invisible forces in our universe? Here to tell us is one of the researchers involved in the project. CSIRO scientist Alec Thomson works at the SKA Observatory in Western Australia and joins me now from Perth. Thank you very much for your time. It's good of you to join us.
Thanks so much for having me, Catherine.
So look, let's just first of all get this one out of the way. What exactly are magnetic fields? What do they tell us?
So magnetic fields are actually a fundamental part of our universe. They're fundamental like gravity. It's part of what makes up the entire universe. They control how things move through space, in particular how electrically charged things move through space. And this has big impacts across the entire universe and then all the way down here on Earth, of course.
So what would we look like here on Earth without them?
In fact, life probably wouldn't be possible here on the Earth. So Earth has its own magnetic field that actually deflects the sun's wind away from it. Galaxies have their own magnetic field. But an interesting comparison, for example, is that we know that Mars no longer has a magnetic field, and we think that's related to why it no longer has an atmosphere and maybe doesn't have life now.
Okay, so what have scientists exactly found here with this new mapping when it comes to magnetic fields?
Sure. So we've actually made a map of the entire universe's magnetic fields. So we've used the most powerful radio telescope in Australia called ASCAP to look towards the distant universe. So we look towards really distant galaxies, and we use the light from those galaxies to light up magnetic fields in the foreground. And so most of what we see in the map is structure from our own Milky Way galaxy, but buried in that same information is what we can see of magnetic fields across the entire universe.
So apart from these being absolutely stunning pictures, what do you as a researcher and a scientist do with this information?
So this is where we can start to dive into a huge range of different types of studies and look at different parts of the universe. So my background is looking at the Milky Way. So these large bubbly structures. And what's really surprising from this map is actually kind of how rough the Milky Way looks. There's a huge amount of detailed structure that we've never been seen before. As we look closer, though, we start to see more distant galaxies and how strong their magnetic fields are. We actually don't know how magnetic fields started in the universe, and we don't know how they've changed across time since the Big Bang. And these are the types of questions we can start to answer now.
Yeah, I mean, are we any closer to understanding some of those really big ideas on how they influence the formation of galaxies, how they look at the formation of stars?
Yeah, exactly. This is the first big step we've had in nearly 2 decades in this type of information to where we can start to answer those questions. And this is what this new generation of radio telescopes allows us to do. And so magnetic fields have a really strong impact on how galaxies form stars. They slow down the movement of gas around those galaxies and prevent the formation of new stars. And so we know that from the theory, but now we have the measurements to be able to understand how that works in detail using the universe as our laboratory to do our physics experiments.
Now, this map is 5 times larger than all the previous efforts to visualise the universe's magnetism combined, and it is the SKA telescope that has been used, or you can explain that probably a bit further. I mean, Australia's really top of the pops when it comes to leading research in this field.
Yeah, absolutely. So ASCAP is what we call a precursor telescope towards the SKA. So the SKA is currently being built and commissioned right now. The SKA is 2 radio telescopes, one here in Australia, in Western Australia, on the same site as ASCAP is being built, and one in South Africa. And so telescopes like ASCAP, the precursors, were made to help us learn the lessons and learn how to process the data and give us the first glimpses of what the SKA can give us. And so ASCAP right now is doing very long-term, large surveys. And so this is actually the first kind of rapid survey we've done with this telescope. So there's even more coming down the pipeline. And as you said, Australia is leading the way in this next generation of radio telescopes.
As a scientist in your field, Alec, if you could have one question answered in this space, and that no pun intended, what would it be?
There's so many. It's really difficult to be able to
Can't
understand.
be greedy. You've got to pick one.
No, I think picking to where and how magnetic fields started in the universe. So magnetic fields are what I've been studying throughout my whole career, and it continues to amaze me that we still don't know how or where they got started. So that's going right back to the beginning. Answering that question would just be absolutely incredible.